All right, last sixth grade video of the week. We are doing science, going back into section G of IXL. Today I am going to do either 7 or 8. Let's do 7. It says, how does mass affect force and acceleration? So how does mass, which is like the weight of something, affect how much force it has and how fast it can move, essentially? All right, several drivers are pushing their cars down the road because the cars ran out of gas. Well, they just get more. Why are they all doing this? So there's a blue car that weighs roughly 4,000 kilograms, a gold car that weighs roughly 3,000, an orange that's roughly 4.5, a silver that's again close to 4.5, and a yellow that's almost 5,000 kilograms. These cars have the same acceleration as the drivers begin to push them. Order the colors of cars to show the size of force applied to each car. So it needs to know which one took the smallest force and which one took the largest force. This is me going fresh in at this. I haven't really done sixth grade science stuff in a while, so I think the way you put it in order is going to be like the lightest car is going to be the easiest to push, the least amount of force taken. So the lightest car was the gold car, so that one's going to be small. Next up would be blue. So gold, blue, and then the silver car is slightly less heavy than the orange car. So silver, then orange, and then yellow should take the most amount of force because it's the heaviest. Hopefully I'm right. Hey! Irma delivers newspapers on her bicycle. She carries one type of newspaper in a bag attached to her bicycle each time she rides. So the beginning of the week, it's 6, the holidays are 4, midweek's 2, special edition 3, weekend 5. So those are like different parts, different times when her bag weighs different amounts. So her bicycle has the same acceleration at the start of each of her deliveries. Order the newspapers to show the size of force she applies to the bicycle when starting each delivery. So again, the heavier something is, the more force it takes to get it going. So the lightest one is going to be the easiest. The lightest one is midweek. So that's going to be a smaller force. So we go 2. Special edition is 3. That's the next smallest. Then holiday, which is 4. The weekend is 5. And the beginning of the week is 6. So the lightest takes the least amount of force. The heaviest takes the most force. Some pilots of hot air balloons are getting ready to launch their balloons. Each pilot lights the flame to heat the air in her balloon. The surrounding air applies a force to each balloon to lift it up. So these are the masses of the balloons. Again, it's asking the size of the force applied to each balloon. So again, the lightest one is going to be the least amount of force. The heaviest one is going to be the most amount of force. So our lightest balloon is this cyan. Cyan, I think, is like a blue color. So cyan, then our next one is going to be violet. It's 2,300 kilograms. Where did violet go? Oh, it's already there. Ha. And then coral, because 26 is less than 28, followed by turquoise, and then magenta. Lightest takes less force, heaviest takes more force. And we're gonna jump to the next stage. So now it wants to know the size of acceleration the acrobats will have as they are being thrown. So this is kind of like the same thing, but now we're doing acceleration. The catapult applies the same force to each acrobat's feet. Order the names of the acrobats to show the size of acceleration the acrobats will have as they are being thrown. I'm not 100% sure, so I'm not going to say anything on this one. And then if I'm wrong, it'll tell us how to do it right. And if I'm right, then I'll tell you what I did. So wait, I want to do it this way. Dang it. So what's this say? A force is a push or pull. When a force acts on an object, the force can change the object's motion. You can tell how quickly an object's motion is changing from the size of the object's acceleration. If two objects have different masses, applying the same force to each object will give the objects different accelerations. The object with less mass will have a larger acceleration. I did it vice versa. I was thinking if it had more mass, it'd accelerate faster. Don't ask me why, this is just kind of what I was thinking. So less mass has more acceleration. All right, got it. So less is more. Huh. So this is about darts. They apply the same force, it wants to know the acceleration. So less mass is more. So our smallest mass is 18, followed by 19, followed by 20, followed by 21, and then 26. What? Oh, I did that backwards. This is why we need to pay attention. So the smallest one is going to be on top, the lightest is going to be on top, the heaviest is going to be on the bottom. All right, so get that in your head. So the lightest stone is gray. It'll have the largest acceleration. Then speckled, then white, then black, then brown. The lightest will have a larger acceleration. Yay, I did it. I'll do one more like this. So again, it wants the largest acceleration to the smallest. Largest is going to be the lightest, smallest is going to be the heaviest as far as acceleration goes. So Monday is pretty heavy. Tuesday is the lightest day, so that's going to be on top, followed by Wednesday, followed by Thursday, followed by, Monday's going to be the heaviest. So Tuesday is the lightest, then Wednesday, then Thursday, then Friday, Monday is the heaviest. So the less weight has a larger acceleration, more weight has a smaller acceleration. And we'll jump up again. This one, the dogs always pull the sled the same force. Order the loads to show the size of acceleration. So again, this should be least heavy, it has the largest acceleration. Oh, this is just making us do some calculations. So 10 fuel cans, each fuel can is 500 grams. That's going to be 10 times 5, I think it's 15,000. 20 food packages. I should probably write this down when we get out my handy dandy screenwriter. All right, so we have 5 times battery packs are 800. 0, 0, 8 times 5 is 40. So that's 4,000. Blankets are 1,000. That's 2,000. Food packages are 700. It's 20, 0, 0, 0. Ooh, I didn't give myself enough room. $700 times 20. 0, 0, 0, 0, 0. 14,000. And 10 fuel cans times 500. That is a 5, I promise. 0, 0, 0, 0, 0, 0, 5. 5,000. So we need to put it, the least is going to be on top, The least was 2,000, which goes with the blanket, so I see a problem with what I did. Battery packs was that, fuel cans. All right, so the least is blankets, the most is food packages. My numbers kind of got all messy. It'll be okay. Don't you miss that noise, my phone going off? All right. One more and we'll call it a video. Workers in a warehouse are moving supplies on carts. The carts are identical, but they are holding piles of different objects. The carts have the same acceleration when the workers begin to move them or to the supplies to show the size of the force applied. So the heavier something is, the more force it takes. The lighter something is, the faster it accelerates. That's what we take away from this today. So we have 2 bags of cement. So that would be 50 times 2, which is 100. So how heavy that is, 100 kilograms. We have 10 metal rods times 3. This is easy, that's 30. Plastic pipe, there's 5 times 2, that's 10 kilograms. And then there's 20 wooden boards. So we have 7 times 20, which should be 140. So the largest force is going to be the thing that weighs the most. So the wooden boards weighed the most, then 2 bags of cement, then the plastic pipes. Nope. Yep. Wait. 5 times 2 is 10. No. Oh, sugar. The wooden boards were definitely the heaviest. Then the bags of cement. I think then the metal rods, then the plastic. So the heavier something is, the more force it takes. The lighter something is, the less force it takes. Yay, and I didn't mess it up. All right, so if you guys have any questions or if you need me to explain anything further, just let me know. If not, enjoy your week.